Hello everyone. Today I'll be explaining a very important concept, optimization of loss function and best fit line using gradient descent. This topic lies at the heart of how machine learning models learn from the data that we cater to them. We'll see how the best fit line is found in linear regression, what the loss function means, and how gradient descent helps in optimizing it to get the best results. What is a loss function? Let's start by understanding what is a loss function. A loss function measures how well our model is performing. It gives us a numerical value, which is basically an error score. For linear regression, we often use the mean squared error, which is MSE, as the loss function. Mathematically, it is written as the given formula where yi is the actual value, y cap I is the predicted value, and n is equal to number of data points. The smaller the loss, the better our model fits the data. The goal of optimization is to find the model parameters like slope and intercept of the line, which is the m and the c, which we will see in the upcoming formula. We find the slope and intercept of the line that minimize this loss function. Next. Understanding the best fit line. In linear regression, we try to draw a straight line that best fits all the data points. The equation of the line is y cap equal to mx plus c. Here, m is the slope and c is the intercept. The aim is to choose m and c such that the line is as close as possible to all the points. That is, the total error, which is the loss, is minimum. So basically, what we do is we try to find m and c in such a line, in such a way that the line that goes through them are the minimum losses. Next, gradient descent. Uh, we use an optimization algorithm called gradient descent to find those m and c step by step to reduce the loss. Mathematically, the formulas are m new equal to m old minus alpha into del L upon del m, and c new is equal to c old minus alpha into del L upon del c, where alpha is the learning rate. It controls how big a step we take towards the minimum. If alpha is too large, we may overshoot the minimum. If too small, learning becomes very slow. Now we will understand the concept using an example. Let's take a small example. Suppose we have three data points, 1, 2, 2, 3, and 3, 4. We start with random values of m equal to 0 and c equal to 0. Step 1 will be predict values using y cap equal to mx plus c. Step 2 will be compute loss using MSE, the mean squared error. Step 3 will be compute gradients, the partial derivatives. We will use the given formula for this, and we repeat and we keep using the formula until the loss stops changing much. That means we have found the best fit line. What we mean here with the statement that loss stops changing much is that the difference between the consecutive losses is not high enough. For example, for the taken example points, we have for the first iteration m equal to 0.3, c equal to 0.2, and loss is 2.8. And for the second iteration, m is equal to 0.45, c is equal to 0.35, and loss is 1.9. For the third iteration, m is equal to 0.55, c is 0.48, and loss is 1.2. So here we can see that for the first and second iteration, the difference in loss is higher compared to the difference in loss for the third and second iteration, and we continue this until the difference in loss is not very high. Conclusion. So to summarize, the loss function measures how wrong our model is. The best fit line minimizes this loss, and the gradient descent helps us find the line by iteratively adjusting parameters in the direction of decreasing loss. This concept is not only used in linear regression but in almost every machine learning algorithm also, from neural networks to deep learning models, as they all require data to train them. Thank you. My name is Krishna Rajput. Roll number EDS 77 PRN 2023 011 00010. Thank you.